Section 12.3 is goodness of fit test for Poisson and normal distributions. In this video, we're going to look at Poisson distributions, and the test is a chi-square test. The hypothesis is the population follows Poisson distribution in the null hypothesis, and the alternative hypothesis is the population does not follow Poisson distribution. So let's look at an example now. This is from your text. In this example, we are looking at customer arrivals in a food market in Tallahassee, Florida. The manager wants to know whether the customer arrivals follow Poisson distribution. So to test that, we first define the arrivals in terms of the number of customers entering the store during a 5-minute interval. So we set up the hypothesis as the number of customers entering the store during 5-minute interval has a Poisson probability distribution as the null hypothesis, and the alternative is that it does not follow Poisson distribution. So the next step is to take a random sample of 5-minute intervals and record the number of arrivals during those 5-minute intervals. So here is the sample. So we have selected randomly 128 5-minute intervals, and then we look at how many customers arrived during those 5-minute intervals, and that information is summarized in this table. So what this means is that there were 2 5-minute intervals with no arrivals at all. There were 8 with 1 arrival. There were 10 5-minute intervals with 2 arrivals, and so on, and totally 128 5-minute intervals. In these samples, the number of arrivals were 0 through 9, but theoretically it can be 0 through any number. The next step is to calculate the sample mean, and we will use that sample mean as our estimate for the mean of the Poisson distribution. If we have the raw data, if we have all the 128 5-minute intervals and the number of customers arriving in those 128 5-minute intervals, we can simply add them up and divide by 128, and we will have the sample mean. But what we have here is only a frequency distribution of the data. So we have the number of arrivals and then how many times that number of arrivals occurred in that 128. So it's not simply a question of adding up. We need to compute a weighted average. We need to weight each of these number of arrivals with the observed frequencies, and therefore the formula is in Excel sum product range 1 comma range 2. So range 1 is the cell range containing the x values, and range 2 is the cell range containing the frequencies. This will give us the weighted total, and we have to divide by the sum of the weights, and that is sum of the frequencies, which is range 2, and this will give us the mean of the sample, and that sample mean can then be used to figure out Poisson probabilities for each of the x values. And in Excel we can use Poisson dot dist and the x value comma mean, and then 0 here indicates that it's not the cumulative probability we want the individual probability. Now we can set x equal to 0, 1, 2, 3, and so on, and we will have the probability distribution. So it will be something like this. So 0, 1 going all the way, and then these probabilities come from Poisson dot dist function. Okay, and then here are the observed frequencies that is given. Now you have to make sure that the probabilities sum to 1. So in some instances we may have to adjust the last probability to make sure that the probabilities will sum to 1. Then the expected frequencies are the sample size times the individual probabilities. So n times p sub 1, this will be n times p sub 2, this will be n times p sub k. Then the chi-squared computations are like before. observed frequency minus expected frequency squared divided by the expected frequency. And add them up, and you get your chi-squared statistic. We need to make sure that all the expected frequencies are greater than or equal to 5. If this is not so, we may have to combine some x's either at the top or at the bottom to make sure that the expected frequencies are all greater than or equal to 5. And then we can find the p-value using chi-sq.dist.rt. And in this case, the degrees of freedom is k minus 2. And based on the p-value, then we can make a conclusion.